The objective of this video is to explain why the optimal amount of compression is impossible or hard to identify. So what is compression? At some point we reach a physical limit of how fast we can send bits, and if we want to send a large amount of information faster, we have to find a way to represent the same information with fewer bits. We must compress the data. So that's what compression is, sending fewer bits. That's it. Compression is sending fewer bits. So the compression widget in this lesson, students will use the text compression widget to compress segments of English text by looking for patterns and substituting symbols for larger patterns of text. After some experimentation, students are asked to come up with the process or algorithm for arriving at a good amount of compression despite the fact that there is no way to know what is best or optimal. In developing a so-called heuristic approach to this problem, students will grapple with the trade-offs in compressing data and begin to develop a sense of computing problems that are hard to solve. So yes, compression is one of those problems that are hard to solve. And there is a sweet spot to compression. So right here is what the compression widget will look like on your end. You'll have some symbols and then words, and your job is to decode that into an original message. So if you look here, the star is a substitute symbol for the snowman, and I think that's a snow falling. So if you take what the snowman means, which going up here, snowman means P-I plus the umbrella. So, okay, the umbrella is the word T-T-E-R space. So P-I-T-T-E-R, pitter. So the snowman is pitter, and then the snow falling is P-A umbrella. So that's T-T-E-R again, so patter. So this is pitter, patter, pitter, patter. That is the beginning here. So it says pitter, patter, listen to, and then sunshine. Sunshine says the. Okay, so you just continue to do what I have shown you to figure out what the original message is. And here is some information for you. The compression percentage is right here. So using just this key, we are able to do a 40% compression. The original was 93 characters long. After compressed, it was only 56 characters. So we're looking at a difference of 37 characters, thus the 40%. So I was able to take this message and compress it by 40% into this. And if I just sent this across the wire, I'm sending fewer bits than if I was to just send this with the normal ASCII encoding we've talked about. So, I love competition. We'll do a little bit of that in class today. The directions are: look for patterns, repeated words or phrases in the text. Enter the patterns you see into the dictionary on the right. As you type entries into the dictionary, the symbol for the entry is inserted into the text in place of the pattern. So what I'm saying is whoever at the end of today has the highest compression percentage wins. And you can just raise your hand, let me know the highest that you or your partner has gotten, and I'll write those names on my notebook. To get to the compression widget, you go to this link right here. So you type that in. And it says why. Think, write, share. Why do you want to compress anything? What is the point of it? A little hint here. I'm saying let's lean heavily on your day 1 of Unit 2 lesson. Think about all the things we talked about on that day in terms of memory size and bandwidth and such. Here's some extra credit for you, if you laugh at my jokes. So text compression is sort of like this. The boss here, the manager, says, ASOC, take these project summaries and summarize them into one summary. And when you're done, take that summary and summarize it. So DOL for the day. We spent most of our day messing around with that compression widget, trying to get the highest possible percentage, which is great. It says, why is compression a hard problem for computers? So why would this whole activity we did today be difficult for computers to do? Draw on your own experience compressing text with the compression widget. Is there a way to know when you've compressed it the most? And explain why you can or can't know. I do have an example response here for an exemplary score. So a good response would mention that compression is hard because there are too many possible ways it could be done to reasonably just try every possibility. This means that you can never really know whether an exact or optimal solution has been reached, at least not in a reasonable amount of time. The response might mention the need to come up with a heuristic, but a perfectly good response might not mention it.